Waller. I'm the dev advocate / trust dev of Phala Network. This is like an introduction on developing fat contracts. We have both spellings here if you want to check them out. And here's some information from me. I tried to get Hash Warlock on all social medias and messenger apps, except for Instagram. Don't look at the Instagram one. Put an underscore, please. Yeah. I also went to school here at the University of Texas. I graduated back in 2015, and I also, like Wenji was saying, I participated in the Encode Hackathon. It was actually my very first hackathon as well, and what I implemented there was a auction bot where I was using the fat contract to query Remark NFT's API so that I could get the information and help them run a ghost auction. And because right now their marketplace didn't have a auction system, and so don't say that. Let's move forward. So I'll hold this here. Our core devs are waiting to answer any of your questions in Discord. So if you have any very deep technical questions, go into the hashtag dev channel and ask your questions there. Let's see. Leave it there for a second. All right, here's kind of the contents of today's demo. First, we'll kind of give a brief overview of Phala Network, a little explanation on fat contracts, and some reasons why we decided to deploy this type of model versus the EVM smart contracts, and how we solve a lot of the limitations of EVM-based smart contracts. Then I'll do a couple of demos. The first one, I'll show you how to do an attestation claim through GitHub, and you'll be able to claim a POAP code through this as well. And then the next one, I'll show you how to do a cross-chain query using HTTP request from the fat contract, so that you can query information about an NFT collection called Nouns DAO. And we use Subgraphs Indexer, and we're able to get that information, display if we can actually afford a noun today based on the auction price. And then I have some links for some more readings. So what is Phala Network? Phala Network is a Web3 computation protocol. We utilized the trusted execution environment to have a privacy-preserving computing cloud. And right now, I believe we have over 10,000 or so workers and secure enclave workers. And and then we're also able to do a lot more, and I'll go into more details. So here's a little idea of the Web3 computing cloud. Today in the Web2 cloud, there's no decentralization. It's not trustless. It's fast, low latency, good services, but centralized, and you kind of adhere to whatever the most popular Web2 cloud is. For blockchain, typically they're missing out on that privacy and scalability, but everything's decentralized and trustless. And the Web3 cloud, we kind of want to bridge that gap by being able to attack all 4 categories of having decentralization, being trustless, private, and scalable. And here's just a high overview of the secure enclave technology using the trusted execution environments. For example, using Intel SGX. It's a hardware-based memory encryption, CPU-level isolation, and you're able to run your applications confidentially, and you can ensure that the execution has integrity and it will execute as the contract is written. how is our Web3 cloud different from the blockchain? So today, as you can see, Ethereum, not E 2.0, but without sharding, you're not able to scale through Ethereum, so everybody's competing for consensus with their computation. And so then there was actually, like Dr. Gavin Wood had written the I believe the yellow paper, I think, for Ethereum that described the EVM bytecode and Solidity programming language that enabled people to program on top of Ethereum. He split off and founded, I believe, Harry Technologies, I believe, but he had written the Polkadot paper and started building Polkadot in 2016, where in the paper they have a number of like 100 parachains will be able to connect to the relay chain so that you can do cross consensus message passing and have a lot more use cases. And so from there, Phala network is actually a parachain on Polkadot and Kusama, and we're able to actually linearly scale due to having our off-chain secure enclave workers, and the more miners that are mining on our network, it scales linearly that way instead of every miner competing for consensus. So here's a little background of what a typical smart contract versus fat contract is executed. So we'll start with like on-chain computation and then kind of go towards the off-chain computation model. So here, as you see, this is the smart contract execution state. Here you're gonna have to wait a long time for any kind of request to the blockchain, because you're gonna have to go to the chain while all that computation is, all the nodes on the network are gonna have the, be competing for that same computation. So you're gonna have to wait and get that on-chain execution, or wait for your request. And this is very limited. It doesn't scale well, and that's pretty much why you see a lot of metaverse projects today not really releasing much or having very severe limitations with scalability. And here's the off-chain execution model here. So we have our substrate node with our transactions, block production, and here we have our off-chain secure enclave workers. So here you're able to send your commands to the off-chain workers and get your queries instantaneously. And if you're sending a transaction, it will then send it to the blockchain. And we have like a different architectural model that I'll go into a little bit later, where we have a message broker, pretty much like a message passing between the Phala blockchain, which is kind of more of being used like a database, and then our P runtime, which is where our off-chain secure enclave workers are. So here's a little description. Fat contracts, off-chain computation model. We have the network connection with a complex computation that takes a long time. We're able to solve that. We're able to have zero latency queries with a very high throughput, so you can do a lot of computationally intensive tasks in our fat contracts. And then we combine that with Phala blockchain with a computational computing cloud with trustless and decentralized privacy, and offers a scalable computing cloud. So this is kind of like a description of why they use an on-chain model. And just to kind of give a high-level overview, because most workers on Ethereum, they could be lazy or malicious, so the execution results will be uploaded and voted by all the workers, so they can come to consensus and have the same view of the state of the blockchain. And so this is kind of going into why we can do it off-chain, and this is because of our secure enclave workers that are off-chain. We have confidentiality, integrity, usually utilizing the trusted execution environment. So off-chain computation with fat contracts. So one of the things that we do, so Polkadot has a smart contract platform called Ink, and that's developed in Rust. And inside your fat contracts that we have, you can actually write Ink based smart contracts inside the fat contracts. And you'll also be programming in Rust, like I said, and you'll also have the ability to make HTTP requests through your fat contracts. Here's like a little high-level architecture that I had mentioned earlier. So here you have the substrate node, where that's the Phala blockchain, and then you have the message broker, pretty much the ferry, that's communicating and relaying messages back and forth between the Phala blockchain and the P runtime, where our secure enclave workers are, and where your contracts will be executed. Your front end, we have a JS SDK, so that you can write a front end for your fat contracts and be able to utilize the powers of the fat contract that we offer. So here's like a little comparison between smart contracts versus fat contracts. So typically latency for a smart contract is going to give you around 12 seconds, while a fat contract is near zero latency. Computing power, smart contracts are limited to one worker doing the computation, and we can actually scale this by the amount of off-chain workers that we have. We also have the trusted execution technology, so that we can create secure enclaves to ensure your privacy, and HTTP requests allow you to have internet access. So the possibilities for developers start to open up a little bit more, and now you have a platform where you can kind of get really, really creative with your implementations and start like letting your imagination run wild. So here's like a little description of what could be built on top of Phala. So from a confidential standpoint, you can have confidential auctions, a deck start pool for like scalable computing power. You can have like AI model training, or say you want to deploy Blender, which we've already shown, and render NFT images or render your game. For low latency, so like MMORPGs, we have we're able to handle the demand from many users, and then also have that low latency to get closer to like real-time games. And then for like internet access, we list here like an Oracle. You can also configure a bot and be able to send messages to say like a Telegram group, Discord channel. And then also, what I'll show later is making cross-chain HTTP requests to get information from other blockchains. So first I'm going to show you the fat contract demo with the identity attestation. And let's see, I'll be kind of doing more live and showing you the process of setting up your which repos that you need to use for the fat contract demo. And this is also part of one of the bounties where you claim a co-op. So I'll start working here. See what's next on here. So this is kind of more of quick second. Get something set up. But in the meantime, how many developers here have written in Rust? 1, 2. Okay, and how many people know about the Polkadot ecosystem? Okay, that's good. I'll be here a little bit tomorrow. Message me on Discord or in the dev channel, and I'll come by, help you understand some of some of the barriers to like entry for fat contract development, like writing in Rust and being smart contracts, and then also understanding some substrate. If you have some questions there, I can show you any kind of resources and kind of give you any information that you may need. So, for the attestation demo, we're using the fat contract as some like a sort of like root of trust. So from here, I'm going to show you in our front end, it'll have a little gist that you'll copy and then you'll post to your GitHub, and you'll make sure to make it public, and then the fat contract will then execute and verify your gist through an HTTP request. That attestation is signed within the secure enclave worker, and that signed report is then verified on the blockchain, and then whenever you're redeeming your POAP, the POAP code will appear in the front end as I'll show you. So here's like what you'll see whenever I start doing the development. Each fat contract has an identity key, and that identity key will be used to sign the message and prove that it really came from the contract. And this is great to combine with HTTP, because then now you can validate off-chain data. So now you can go out, retrieve information, and then you know that based on the signature, you can verify that it was indeed the fat contract that pulled this data, and it's verified through the signature. So then this is how you can produce on-chain attestation. And I'll go into this a little bit more, but now I'm gonna start the demo, and let's get my third arm here. So if you go into GitHub, if you're following along, I'll grab this one over. So in our GitHub, you can find this Phala-network. And I'll go to the top page here. This is our page on GitHub, and here we will be I'll be showing you like the fat contract workshop here. So this is one of the pages you will need. The next one is the JS SDK. So this is for your front end deployment. It has our SDK for interacting with the fat contract, and also some of the Polkadot API and the Polkadot API contract for the ink-based smart contract calls, and that will be right here. So I'll open up these two tabs, and then kind of give you an overview here of what the fat contract workshop is. In this one, you can use the master one for the first demo, and I'll update the repo for the consensus 2022 cross-chain example as well. So this will be the fat contract that you will pull from GitHub, and then you pull. So I use C-Line. But a lot of developers in the Polkadot ecosystem use VS Code. I just really like JetBrains and how I can search easily. I just got used to it, but anyways, here's an example of, let me clean this. Okay, so in the terminal, you'll want to go through the README, first, actually, and then kind of like follow the instructions of like what packages you need to download, and you need to have like Rust installed, but also you have to do a couple extra steps of ensuring you're running the right nightly version, and so it's compatible with the ink-based smart contracts. Whenever you're compiling your code, this is what you'll do. You'll run cargo plus nightly contract build, and this is how you build your contracts. And this will, so you see a target here, this will create a target folder with /inc, and then you'll have your .wasm file that you'll be using to upload to the Phala to the Phala Polkadot.js website, and that will look like this. So here I'll just do an example of what it would look like executing. Perfect. So here you see it generated fastsample.contract. This is we won't be using this today, but we'll be paying attention to this fatsample.wasm code blob, and then the metadata.json file for the front end. So whenever you're using, you'll be using polkadot.js.org. So here I'll show you what that looks like. It's pretty bright, but here is the development node for our testnet, and polkadot.js is I know y'all don't program on this. It'll be a little confusing, so I'll just kind of show you. You'll need to go here, and under testnet works, you will need to access Phala POC 5, and then hit switch whenever you want to switch to that network. You also need to just show you where to download the extension for polkadot.js. Here you will go to extension, and this is where you can download for Chrome or for Firefox, and this is kind of like an overview of what it would look like and how you would generate a wallet for this demo. One thing to make sure is whenever you have, I'll be using in this demo Fat Warlock. Make sure that you have allow use on any chain for like whenever you're developing on the testnet. And then in the I believe in the README instructions, there's an account where you can send some Phala tokens to your test account and be able to upload your contract. So now I'll keep this state open here with the Explorer just to kind of show like exactly what the process would look like. So and then so then next you will need to go into extrinsics, and this is where you'll upload your .wasm file to the Phala blockchain. So here I have my Fat Warlock account. You then want to go to Phala Fat Contracts here, and then on the third option down, you'll see Upload Code to Cluster. So here, you'll have the file upload here. You'll click, and then grab your fat sample and upload it, and then you should then see something like this here. And this signifies that the code is uploaded, and you'll get a hash here of the .wasm file that's uploaded to the blockchain. So you'll hit copy this, and then go to your contracts, instantiate contract next, and you'll hit WASM code. So make sure you don't use native code, just use WASM code. And where I copied that hash, you'll insert that here. Next, where it says data, you want this because this is your constructor hash, and you can find this in the metadata.json file. So when I go back to the IDE that I'm using, I'm gonna go into that target folder, go to inc, and then metadata.json. So here you'll find where the constructor is here. You want to get this selector and copy this and insert that for the data parameter. So go here, and you don't have to do anything complicated. Just like OX1, and then you'll hit submit transaction, sign and submit. And then sign the transaction, and as you see, that the contract is in the box, so then you can have your Explorer open, and you can see that it's instantiating here, then instantiated, and this is what you'll need next for the next steps, the contract key here, the contract public key, and you'll want to save that up. So next, I'm going to deploy the front end to show you how to interact with the attestation claim. So I will be bringing JS SDK. So right now I have it running already. And in here, you'll see that whenever you pull down the JS SDK repo, it'll be a little bit different than this, but you'll go into examples, you'll see pages, and the redeem POAP code front end page is right here, and you'll need to follow the steps in the README for the workshop, and then deploy your front end. So I have mine deployed right now, and I'll bring that up. So let me go back just to show you exactly how the code started. So here, it's just like a boilerplate sample page of the Phala SDK example. The two pages that we'll be paying attention to for the two demos are redeem POAP and then can I ape into nouns tab. So we're gonna do the redeem POAP first here. And so when I mentioned the contract ID, here. So you want to copy this here, and in the README they'll have the WebSocket endpoint that you'll need to use, and then the p-runtime URL, which will be the worker cluster, I believe. And then here in the contract ID, you'll insert the contract ID, and then that metadata.json file that I mentioned earlier will then you'll copy the contents here from the generated build, and then you will paste that here. So then I'll load the contract, and the contract's loaded successfully. I'm going to assign the certificate, and here it is here. So the instructions are, it wants me to create a gist on GitHub, verify the gist URL, and then get the POAP redemption code. So in this example, I deployed this contract, so we need some POAP codes to generate and then delegate to the users. So here in this dev options, make sure whenever you're doing the bounty for, I guess the challenge, the first challenge for the hackathon, to make sure you put some codes here. So here I'll put make So this would be just an array of codes that can be distributed. So I could distribute 5 pull-up codes. Since it's an admin function, we'll have like the administrative control there, and in the fact contract, and then sign the transaction. So this there we go. We have the transaction is finalized, and now we have some pull-up codes to redeem. So here, I'm going to show you going to GitHub and then creating your gist. So copy this, go to gist.github.com, copy the contents here, gist, call it like me. And you want to make sure you make it public, and then create public gist here. Now that's here. Make sure that if you want to claim it, you'll go to raw, copy this URL, go into the redeem, and paste that here. And that will be the information whenever we do the HTTP request. So we're going to verify, sending the redeem, sign the transaction, and after this executes, then that station should be signed and then verified and there. So take the first one and it'll auto-populate to make, you can copy that and you'll get and then post your little image into our Discord in the hackathon submissions, and that'll be your first, that's how you'll do your first challenge. Now, on to the next, which will be the cross-chain HTTP request to subgraph to get the nouns DAO information. So does anybody know what nouns DAO is? Anyone? One? Oh, nice. So if you want to check it out, it's here, nouns.wtf. Every day they generate an SVG on chain, and they don't have to use like IPFS to point to some file in decentralized storage. It's actually minted on chain, and it's composed of 5 different parts, but the algorithm produces one every day forever, and whenever you purchase a noun, you get a vote in their DAO. So you can see their treasury has 25,402 ETH. Current bid right now is 84 ETH with 16 hours ago. And I created a fat contract that would query the subgraph HTTP endpoint and gets the information to see if I can afford a noun based on what I set as an acceptable bid price. So here, I'll spare you the details of loading the contract and loading the metadata, but here, can I ape into nouns DAO? And that would be here, so I need to insert my information for the contract real quick. So I had another ID like not in the window, so I didn't copy the other. I'll do it just to show you here. Go in here, load the contract, I'm the admin, and that's up the contract. So I'll sign the certificate here, and right now, Now's DAO is 84 ETH, and it's not, the auction's not settled. I'll put 83 as the price, just to sign the transaction. And just to kind of give you an idea of what the curl post command that we're going to run for the HTTP request looks like. Can everybody see this? Okay, cool. So this is kind of like an example of the command. So I have the API URL here, which is HTTPS blah 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 nouns graph subgraph, and then I have my data payload here, or data load here with the query that I created to be able to query the index, the subgraph. And then what I'll expect to see here whenever I get the data returned will be this information here. And I will use, so whenever you're developing, you'll need to use in cargo. So whenever you're defining your cargo .toml file, and since there's not many Rust devs, I'll come back later and kind of explain some of the nuances, but make sure that you'll need the Serde package, and you must have derive, you must have alloc, and you need to use the Serde JSON port. So move forward, just make sure that I have this right. Here. Let's see if I have. Okay, here we set the price. 3. So this will be creating a transaction that will be sent to the Phala blockchain to set the state of the contract, so that we are able to we're okay paying 83 ETH for a noun during the auction. Here, I can see that this is just like a format for translating it from integer to the acceptable ETH format, just for basics. Me right now, as you see, it's like I had run update earlier, so it has 337. This is the 337 noun. And the last bit update was 84. I guess it's still at 84, but I'll just run the update again. So this kind of like here, if you can see here, this is me with ID, amount, settle, and then this is a signature that I signed to show that I signed the data package, the data that was sent back from the HTTP request. And then once I sign this transaction, then I'll verify that this that the information that I retrieved is in fact from the signed key of the secure enclave worker that has with the that contract, and then it will then set the updated data from the request onto the contract state, so that I can then ask if I can ape into nouns. So here I'll just reiterate 337 still, 84 max here. So it should say no, right? So not today. So yeah, I'm unlucky today, can't. So then let's say maybe I am a little bit richer by $4 grand possibly, and set the new limit just to kind of show if so the price set successfully, and then can I pay? Not today. Wow, nice. Now it's recently been on. Now it's updated. So that was like that was an example right there of how fast the queries are, and it was whenever we queried, it was instantaneous. So it had not even updated on the blockchain yet for 85, but now it's updated, and now it says I can afford it. So this is just like an example of what you could build. There's many other use cases, and I'm really interested to see what y'all build, because you can get real creative. And if you want to bounce any ideas off of me or the Phala team, we can answer your questions in Discord, or you can reach out to me directly. I love discussing ideas, especially since people are really capable and they do a really great job developing. So I think we can all make each other better, and that's kind of how it was whenever I attended my first hackathon. I was able to, the first place winner was a really good builder, and I was able to ask him questions and kind of see how he architected his project to win the hackathon, and it also helped me push forward to be able to put my implementation out there. So let's get to the last part. So this is just kind of like an overview of like the syntax of what HTTP request would be. So to read, like these are some examples. You could do a token price, tweets from Twitter's API, GitHub repo, files from AWS, files from Arweave. These are kind of like files from Arweave. So does anybody know what Arweave is? Yay, yeah, Arweave, yeah, it's decentralized storage, but it's permanent. It's not like how IPFS is, where you gotta pay a little bit of money, keep your files in storage. To-dos, so like these are things that you could do as well, like whenever you're using the HTTP request to post data. So like say you want to send a message to a Discord group, or you want to send an email through an API service, or whichever, you can do that by utilizing an example like this here, where it says post data, and then this is the HTTP_post exclamation mark, where you'll have your URL here, and you'll need to create a data payload and make sure that it ends up being a VEC and a UA, which you can see here. Like that's what I'm talking about when it comes to Rust. But y'all have questions, just ask me and I'll show you. And if you have any problems, I'll show you how to appropriately format it. And if you're reading it, if you want to if your response is in JSON, you can look at my example and see how you have to use the currently limited library of Cerde JSON core, and you'll have to understand a little bit about like lifetimes with structs and Rust. But I can help you format it and make sure that you get the answers you need before the submission on Sunday. We also have like a very small like local cache that you can use. These are just like little examples of like a key value cache, but this is not shared across all the workers, and it's volatile, so it's just stored for immutable functions. I just did that, and I was just kind of like me doing the HTTP request for the current auction, creating signing of the data payload that was returned, and verifying on-chain. Some of the examples of the previous hackathons. This is the one that I participated in November. Secret MD, so it's just like encrypted markdown on confidential Phala blockchain. You have the Phala Pass, which was an extension in your browser and uses the TE to store your passwords, so no one can have access to your passwords except for the person with the admin key to the vault, so they can get it. And then this is just like one of the bots that I did. And to learn more, there's some information here, like introduction to fat contracts, tutorial. We also have something on YouTube where our lead researcher, Shelvin, Dr. Shelvin Zhao, he has a very thorough explanation of what fat contracts are, and he'll give you a better description than maybe I would. But he's really a good source to ask in Discord, along with our co-founder and lead dev, Hong Yin, and then we have other core team devs that are very, very talented and can help you out if you have any questions. Any questions for the moment now? So is anybody going to use this? Who wants to build on here? Anybody? Well, if you do have any questions, just please reach out, and I will help you. If you want to maybe utilize one of the workshops that you see today or tomorrow, and try to see how y'all can communicate and use Phala Fat contracts to collaborate with another project, I'll try to help you as best I can. Thank you.